The materials that we need in this experiment is BOD bottles, 250 ml conical flask, 50 ml burette, restored stand, measuring cylinder, beakers, water sample that we use is landfill leachate. Dilution water, starch solution, 0.0125 molar thiosulfate solution, aluminium foil, filter funnel, dropper, 50% manganese sulfate solution, alkaline iodide reagent, 50% sulfuric acid.
Before starting the experiment, we need to prepare 300 times dilution. I am going to show you how to calculate the dilution. We want 600 ml diluted sample for the final volume. We need to find the volume of landfill leachate to dilute. Initial concentration is 300 because each concentration 300 times of final concentration. So the final concentration is 1. By using M1V1 equal to M2V2 formula, we can determine the volume. M1 is 300, M2 is 1, V2 is 600, and we need to find V1. Insert the value in the formula and solve it. Then we get the volume of landfill leachate needed was 2 ml. Now I will show you how to prepare a sample. Transfer 2 ml of landfill leachate into 10 ml of measuring cylinder by using a dropper. After that, transfer 600 ml of dilution water into 1000 ml of measuring cylinder. The volume of diluted sample needed was 600 ml. Then, transfer 2 ml of landfill leachate into a beaker. Transfer dilution water into the beaker until it reaches 600 ml. Aerate the diluted sample for 10 minutes. This method is to make sure the sample mixes well. It is also to increase the oxygen concentration in the water.
A few minutes later.
Next, pour the diluted sample into clean BOD bottle. Pour until it overflows. Make sure there are no air bubbles adhering to the inside of the bottles by tapping the side and insert the stopper firmly. Repeat this step until you get 6 BOD bottles of diluted sample. Next, by the same method, prepare the blend by using dilution water. Pour dilution water into a beaker until it reaches 600 ml. Aerate the dilution water for 10 minutes. Repeat the same method. Pour the dilution water into clean BOD bottle. Pour until it overflows and make sure there are no air bubbles adhering to the inside of the bottle. Repeat this step until you get 6 BOD bottles of blend. 1, 2, 3. Pour the dilution sample
Wrap the BOD bottles containing diluted leachate sample using aluminum foil to be stored for 3 days. Repeat this procedure with BOD bottles containing blank sample.
One set of bottle, diluted sample, day 1. To the other set of bottles, add 1 ml manganese sulfate solution. Followed by 1 ml of alkaline iodide solution. The purpose is to feed the sample so the oxygen exchange will not occur during testing. Place the stopper firmly to exclude air bubble, holding the bottle with a finger on the lid. Shake the bottle vigorously. When precipitate has settled sufficiently, it will leave clear supernatant above the manganese hydroxide flux. And then add 1 ml of concentrated sulfuric acid H2SO4 using a dropper pipette with the tip below the water surface. Place the stopper and mix thoroughly. The precipitate has now dissolved and iodine has been released to give a clear reddish brown colors. Repeat the same step for another 2 bottles. One set of bottle, blank, day 1. To the other set of bottles, add 1 ml manganese sulfate solution. Followed by 1 ml of alkaline iodide solution. The purpose is to feed the sample so that oxygen exchange will not occur during testing. Place the stopper firmly to exclude air bubbles, holding the bottle with a finger on the lid. Shake the bottle vigorously. When precipitate has settled sufficiently, it will leave clear supernatant above the manganese hydroxide floc, and then add 1 ml of concentrated sulfuric acid H2SO4 using a dropper pipette with the tip below the water surface. Place the stopper and mix thoroughly. The precipitate has now dissolved, and iodine has been released to give a clear reddish-brown colors. Repeat the same step for another 2 bottles.
Before beginning the titration process, rinse the burette using distilled water. Then, rinse the burette using the titrant, which is 0.0125 molar of sodium thiosulfate solution. After that, fill in the burette with the titrant, which is 0.0125 molar of sodium thiosulfate solution. Record the initial volume of the titrant. Set up the burette at the retort stand. Measure the volume of 200 ml of diluted leachate sample. Pour the 200 ml of diluted leachate sample into the aluminium flask. Begin the titration process. Titrate the solution using 0.0125 molar of sodium thiosulfate until the diluted leachate sample turn into pale yellow in color. Record the volume of titrant. Add a few drops of starch solution and a deep blue color is formed. Continue the titration until the blue color disappears and note down the burette reading. Record the volume of titrant. Measure the volume of 200 ml of blank sample. Pour the 200 ml of blank sample into the aluminium flask. Begin the titration process. Titrate the solution using 0.0125 molar of sodium thiosulfate until the blank sample turn into pale yellow in color. Record the volume of titrant. Add a few drops of starch solution and a deep blue color is formed. Continue the titration until the blue color disappears and note down the burette reading. Record the volume of titrant.
3 days later.
This is the sample and blank that we have kept for 3 days.
One set of bottle, dilated sample, day 3. Add 1 ml manganese sulfate solution. Followed by 1 ml of alkaline iodide solution. Place the stopper firmly to exclude air bubble, holding the bottle with a finger on the lid. Shake the bottle vigorously. And then add 1 ml of concentrated sulfuric acid H2SO4 using a dropper pipette with the tip below the water surface. Place the stopper and mix thoroughly. One set of bottle, blank, day 3. Add 1 ml manganese sulfate solution. Followed by 1 ml of alkaline iodide solution. Place the stopper firmly to exclude air bubbles, holding the bottle with a finger on the lid. Shake the bottle vigorously. and then add 1 ml of concentrated sulfuric acid H2SO4 using a dropper pipette with the tip below the water surface. Place the stopper and mix thoroughly. Repeat the same step for another 2 bottles.
Before beginning the titration process, rinse the burette using distilled water. Then, rinse the burette using the titrant, which is 0.0125 molar of sodium thiosulfate solution. After that, fill in the burette with the titrant, which is 0.0125 molar of sodium thiosulfate solution. Then, remove the bubbles from the burette. Record the initial volume of the titrant. Measure the volume of 200 ml of diluted leachate sample. Pour the 200 ml of diluted leachate sample into the aluminium flask. Begin the titration process. Titrate the solution using 0.0125 molar of sodium thiosulfate until the diluted leachate sample turn into pale yellow in color. Record the volume of titrant. Add a few drops of starch solution and a deep blue color is formed. Continue the titration until the blue color disappears and note down the burette reading. Record the volume of titrant. Measure the volume of 200 ml of sample. Pour the 200 ml of sample into the aluminium flask. Begin the titration process. Titrate the solution using 0.0125 molar of sodium thiosulfate until the blank sample turn into pale yellow in color. Add a few drops of starch solution and a deep blue color is formed. Continue the titration until the blue color disappears and note down the burette reading. Record the volume of titrant.
There are 3 bottles for each set. This is the volume of sodium thiosulfate that have been recorded. Calculate the average volume for each set. The average value of leachate for day 1 is 8.27 ml. The average value of blank for day 1 is 8.23 ml. The average value of leachate for 3 days is 7.77 ml. The average value of blank for 3 days is 8.13 ml. Note that 1 ml of 0.0125 molar sodium thiosulfate is equal to 1 mg per liter DO. DO is dissolved oxygen. D1 is initial DO in a sample which is 8.27 mg per liter. D2 is final DO in a sample which is 7.77 mg per liter. B1 is initial DO in blank which is 8.23 mg per liter. B2 is final DO in blank which is at 0.13 mg per liter. Meanwhile, P is fraction of the BOD bottle that is represented by the sample, which is 1 per 300. This is the formula of BOD value. Insert the value of D1, D2, B1, B2 and P in the formula and solve it. The BOD value for the landfill leachate sample is 120 mg per liter.
Discussion. In this experiment, we are use Winkler titration method. This Winkler method is used to measure dissolved oxygen DO of the leachate and the blank sample. The amount of sodium thiosulfate Na2S2O3 used in this titration process were recorded to calculate the amount of dissolved oxygen. Dissolved oxygen is the amount of gaseous oxygen O2 dissolved in the water. The purpose of using the blank sample is to control the value of organic material in the sample. Based on the result, the average amount of dissolved oxygen leachate sample Day 1 8.27 ml, Day 3 7.77 ml. Based on the result, the average amount of dissolved oxygen blank sample Day 1 8.23 ml, Day 3 8.13 ml. Biological oxygen demand (BOD) is a measure of the oxygen used by microorganisms to decompose organic waste. If there is a largest quantity of organic waste in the water supply, there will also be a lot of bacteria present working to decompose this waste. When this happens, dissolved oxygen level decrease because the oxygen that is available in the water is being consumed by the bacteria. The lower the level of dissolved oxygen DO, the higher the level of BOD. This is because the demand of oxygen by the bacteria is high, and they are taking the oxygen from the oxygen dissolved in the water. Based on the result, BOD value for a leachate is 120 mg per liter or 120 ppm. BOD level of 100 ppm or greater, the water supply is considered very pollutant with organic waste.
Ways to mitigate water pollution. Dispose trash properly. When trash is not disposed properly, some of the non-degradable products such as diapers and sanitary towels may end up destroying the process of sewage treatment. Proper sewage treatment and management. Proper sewage treatment is required to limit the amount of toxic substance that normally end up in water systems such as lakes, rivers, and oceans. Always opt for recyclable and reusable options. Reusable and recycled materials avoid the unnecessary use of water. By using these options, it means you are conserving water. Keep out oils, fat, or grease from the sink. This is from pouring cooking oil, fat, or grease down the kitchen sink. Instead, keep the jar that collects all the fats, grease, or oil, then discard in solid waste.